Hello. Today we're going to talk about the second part of 4.1, which is quadratic parts. So this one is going to have that homework where you fill out a large table, okay? So here we want to be able to point out key features of a graph, okay? So first we want to make sure we can graph it correctly. So hopefully you remember all your transformations. So our vertex is going to be at 2, 0. And since our a value is 1/2 or 0.5, I'd recommend making a table. So let's see, give you guys a second to do that. You might want to pause the video. Okay. So when you get your table, you should have graphed this. Okay, so some key points on this graph. Okay, I don't know if this is going to be a bad idea or a good idea, but hopefully it's a good idea. If you're unsure about your graph, you should have a graphing calculator, and you should be able to double check it using it. So we're going to go to y equals, and this is where we can plug in our equations. Now I already have x squared, so that's the parent function, so I'm going to leave it just for comparison. And then I'm going to type in this equation. So I'm going to use 0.5 only because it's an exact decimal. If that was 1/3, I would have typed in 1/2 as a fraction. Then do x. So again, okay, make sure you know your parentheses are here. Your x is right here next to your alpha. So x minus 2. Realize this is the minus button and this is a negative symbol. Okay, those are the difference. And then the squared button. And now we can hit, just to make sure our window is okay, I'm going to hit zoom standard. Okay, in case my window's ever a little off. So my blue one, and let's see, and then the red one. Okay, so the blue one here was my, sorry, I did my colors backwards. So the blue is the parent function and the red is my new one. So notice it looks a lot like mine. So it looks like I graphed it correctly. So if we want to make sure, we can trace it. Now here I'm on my blue line. I want to be on the red one, so I'm going to press my up or down arrows. So now I'm on the red equation, which is the one we're graphing. And so since I'm on that trace button, I'm going to type in, hopefully when you guys plugged in 1, you got 0.5. So we hit 1. Notice it gives us the output, 0.5. When you plugged in 0, you should have gotten 2. Notice that's what we got. Plugged in 3. So here it gives us our x and y points. And you're probably thinking, why did you just tell us exactly how to do everything, not by hand? Well, because, I don't know, I guess I'm being nice during COVID, but I want you guys to be successful, and this helps you know right away if you're right or wrong. Okay, since I can't be there to help you every step of the way, this is going to be there to help guide you. So please don't just rely on your calculator to do everything. I want you to be able to think about stuff, okay? Because if you ingrain those transformations into your head, if you get that down, it's going to help you so much further on in pre-calc and calculus. And we have to do those things in IB math as well, okay? So please just don't rely on your calculator to do everything. Okay. So let me get off my rant now. Okay, so back to this. Our AOS stands for axis of symmetry. So here, the axis of symmetry is where we're going to cut it in half. So I can cut it in half right here. If I were to fold my graph along this dotted line, okay, it would be the same on both sides. All right, it would be that mirror we talked about. So that is a vertical line. So hopefully we know a vertical line, hoi vux, this is x equals 2. Do you think it's any coincidence that it's also the same 2 from our vertex? No, because our axis of symmetry goes through our vertex every single time. It should always go through our vertex. So these should always be the same number. Okay? Now, let's see, a minimum or a maximum. A minimum is like a low point. Think of it like a valley. We have the lowest it can be is down here. A maximum is like a mountain. So, do we have a high point? All right, a cutoff point at the very top. So in this one, all right, since we have that smiley face, we're going to have a minimum. And the minimum, the lowest this can be, is right here when y is 0. So this value is 0. It's always your y value. Okay, so this value and this value will always be the same. Okay, I guess I should leave that green one I had up there earlier. All right, the substitution point. Okay, so I know the x value is 4. So over here on my graph, at 4, I had gotten the point 2. So you could have plugged that in, right, with your t-chart. So 1/2 4 minus 2 squared. So 1/2 2 squared. So that's just 1/2 times 4. Oop, trying to go too fast. 1/2 times 4, so 2. So after we plug in 4, we got our output of y, which is 2. So that point is 4, 2. And the reflection point is the one that's across the axis of symmetry. So your mirror. So this one is going to be at 0, 2. Notice it had the same height as the substitution point. It's also, the vertex is, the x value here is in between the 4 and the 0. Okay, the vertex, the 2, is a average, a median. Okay, it's in the middle, midpoint, that's what I was looking for, of 0 and 4. Okay, so there's a relationship between those numbers. All right, let's do another one. So for this one, we're going to get our vertex at -1, -2. So just for visual purposes, I've got my vertex right here. And since the a value is 1, I can go ahead and do my rapid graphing. Slope of 1, slope of 3, slope of 5, and then I can mirror it. If I'm ever unsure, I can use my graphing calculator and double check myself. Then, which honestly, that to me seemed a lot faster than plugging in my calculator and then plugging in the points back and forth. Okay, our axis of symmetry, so what's going to cut it in half is going to be x equals -1. It's a smiley face, so it's going to have a minimum, and that minimum value, the lowest it can be, is -2. The substitution point is 1, so at 1, we were at 1, 2. Again, we could have just, if we could just plug that in. So at 1 plus 1 squared minus 2, we should get 2. And the reflection point, so this is where it's helpful to have your axis of symmetry. I always like to show it when I do parabolas. So here we have the reflection point is going to be on the other side, so it's going to be at -3, 2. I'm going to do a couple more. So this one. So we get our vertex at 0, 3. So 0, 3. Uh-oh, I can already tell ours is going to go off the graph. So 1, 1, and then it's way up here. Okay, rough sketch. Do the best I can. So the axis of symmetry, at least I've got a visual, right? So the axis of symmetry is at x equals 0. It's a minimum, right? Smiley face. So then the lowest it can go is at 3. Substitution point, all right, is at 1, 4. And the reflection is at -1, 4. All right, when I'm talking about the substitution point and the reflection point, these two are related. Okay, let's do another one. We've got to do another one going down. We're going to change this one. We're going to make that -2x squared. So now our vertex is going to be 0, 0. The -2 is going to make it go like this. So way down here, somewhere way down there. Okay, axis of symmetry is going to go through 0. Now it's a high point. Okay, so that's going to be a maximum. All right, the maximum it can be is 0. So you have to tell me it's a maximum, okay, at 0. And then the substitution point, well, this is nice because I can graph it and see that it's at -2. And I can easily see that the reflection point is on the other side. So that's going to be at 1, -2. Again, I also could have plugged it in. -2 times -1 squared. So -2 times 1. Okay, so that was another way to get the same answer. Okay. All right, so hopefully you can fill out the rest of the table on your own. If you have any questions, just come and ask.